All right, here we go. What do we call a line that intersected the circle in exactly one spot? That's a tangent. Well, what if it hits in two spots? Here you go. It is called anybody want to try to secant? Okay, it's called a secant. All right, a secant, a line that intersects the circle in exactly two spots. Here's what I'm going to show you guys today. How do you find an angle that's located on the outside of the circle? And here's the good news. No matter how that angle's formed, if it's on the outside, it's found the same exact way every single time. I don't care what it is, a tangent and a secant, two secants. I don't care how that angle on the outside is being formed. It's going to be found the same way every time. And here, let's just get right to the theorem right now. And here's how it's going to be found. All right? So an angle, come on. Angle on the outside of the circle is going to be equal to the following. What did you guys do yesterday to find that floater angle? Half of the... Okay, but what'd you do with those two arcs? You added them together, right? And took half of them. Today, you're going to subtract them and take half of them. All right? So it's going to be equal to half the difference between the intercepted arcs. Half the difference between the intercepted arcs. So here's what I want to do with you right now. We're going to go around the room. First thing, how is the angle on the outside formed? By two what? And then we're going to actually find we're actually going to write down how to find the angle on the outside. This first one, how's angle B formed? By two what? What are those called on the outside? Don't yell anything out, please. Here we go. They're formed by two. Almost had it. Almost. By two what? 19. Two tangents. All right, so this is two tangents. Here's how you would find angle B, the one on the outside. It's going to be half of, name the two arcs that are in between the angle. That's what I mean by intercepted arcs. Name the two arcs that angle catches. The major one, which is what? Which one is the major one up there that I'll put first? Here you go, 10. Arc A, well, I got two ACs up here. Okay, see, there's two arcs. This one right here and this one right here. I don't want to put the smaller one first because that'll give me a negative answer. All right, so I want to put the bigger one first, the major one. So arc ADC minus the minor one, which would be 7. Arc AC. That's how I find the angle on the outside. You subtract, if the angle's on the outside, stop the discussion. I'm going to subtract two arcs. Next one. How's angle A formed here? By a what and a what? 9. Tangent and a secant. Yep, that's a tangent and a secant. Okay, how do I find angle A? It's on the outside, so it's going to be half of two arcs subtracted. What two arcs would I be subtracting here? Remember, intercepted ones are the ones inside the angle. Give me the first arc, 4. Arc BD, the bigger one. Nice job. Minus arc, here you go, 10. BC. Got it. Everyone's good so far. Angle on the outside, you subtract the arcs in between it. Next one, how's that angle A formed? 1, how's that angle A formed? 2 secants. Okay, tell me how, in one swoop, how angle A is found. It's on the outside, you take half of blank. 2. Arc CE, keep going. Arc BD. All right. If it's on the outside, we subtract. Everybody good? We sure? Okay. Special type of angle. Special type of angle. Just letting everybody know there's about 20 kids in here. I can see everything that goes on. So at least have some respect for me and put away your darn phones while I'm trying to teach. Special type of angle. An angle formed by a chord and a tangent. Everyone see that angle right here? Which is angle BAC. Everyone see angle BAC. See how that is formed by a chord and a tangent. We're all good there. It looks like it's an inscribed angle, right? Because where's the vertex? It's on. So you'd probably say inscribed, but remember what inscribed has to be. The two sides have to be chords, and this one's not a chord. All right? Here's how you find it. You find it the same way as an inscribed angle. You take half its arc. All right? So angle BAC will be half of arc BC. Half of arc BC. Chord and a tangent. Chord and a tangent, you take half the arc. And that would be equal to half of 140, 70. Sean, remember that question you asked me yesterday during homework? And we had to find all those darn angles around it to finally find the one you were looking for? There you go. Now we have a rule for it. That was an angle formed by a chord and a tangent. Yep. Justin.
It's supposed to be arc BA, right? Not BC.
No?
Where's the C supposed to be?
What do you mean?
On the line?
BC. Oh, okay. I see what you're saying. I meant, okay. That's fine. I got you. Okay. I was looking at it as C. All right, here's what I need you. There is one combination of lines we have not talked about. One combination of lines that we have not. We talked about a tangent and a chord. Look back, we talked about two secants, two tangents, a tangent and a secant. There's one combination we have not talked about. Anybody figure what combination we have not talked about? What combination have we not talked about? An angle formed by a what? Sean? Secant and a chord. So that's what I want you to do now, right below this one. And you'll be surprised what my theorem is going to be for you. So here you go. Let's draw your circle. A secant's going to intersect how many times? Okay, so let's draw a line through this circle that intersects twice. And we know what a chord is, right? So let's draw it right from here down. Let's draw a chord. Now, I'm not talking about that angle there, because what type of angle is this one? It's inscribed, so I'm not talking about that one. I'm talking about this one right here, that angle formed by a chord and a secant. And you ready for my theorem? There is no rule. I don't have a way for you to find it. It's not half an arc. It's not add these two, divide by 2. It's not subtract them. But is it impossible to find it? No. I may not have a theorem for you. Tell me how you could find it. Find the inscribed angle and subtract it from 180. So you could still find it. Just because there's not a little rule, you take half of this arc or take half of the two arcs, add it up, right? You can still find it. All right, so secant and a chord, there's no theorem, but you can certainly find the inscribed angle next to it. All right? Okay, buckle up. Going to go hopefully right around the room in here for most of you right now. I'm not going to pay attention to one because we just did that problem in your chord and tangent rule. All right, your chord and tangent rule. We already did that one. Okay, next one. Find arc AB. Which one am I talking about? I'm talking about the minor arc AB. All right, minor arc AB, just so you know. Here we go, 16. Where's 16? 16. Okay, here you go, Maggie. How is this angle, this 160 they gave me, how did I form? With a what and a what? Tangent and a chord. So I think about all my rules. A tangent and a chord is found by taking half the arc. All right. I'm looking for arc BA though. So what's the angle next to 160, everybody? Angle next to it, 2? 20. Will, how is that angle found? Oh, I know, but using the, excuse me, I misspoke. Using the arc, how is that angle found? So you want me to take half of 20? Double 20 because I'm looking for the arc, all right? So arc AB is going to be 40 instead. Questions? Okay. Here we go. Who's got 10? For number 3, where is the angle located that I'm trying to find? Inside or outside? Discussion's over. Discussion's over. I don't care that it's formed by 2 secants. Luke just said, hey, that sucker's on the outside. There's only one way I find an angle on the outside of the circle, and that is taking half the difference of 2 arcs. The 2 arcs in this case, here you go, 10 again. There you go, 90 minus 20. Half of 70, you end up with 35. Whew, all right, everyone have their calculators ready to go on this one. 4, where's that 38, inside or outside? Outside, yep. So I know that 38 was found by taking half of 2 arcs when I subtract them. What's the minor arc? Okay. Now I got a problem now. How do you find the other one then? This one right here, that major arc, because that's going to go in right here. I know that's 140. Anybody? Any thoughts? I really don't want to just give. Go ahead, Maggie. What do you got for me? I think we're on the same page. How many degrees in the circle? You already know this is 140, right? So how much is left for the rest of the circle right now? Go ahead. How much is left for the rest of the circle? 220 degrees is left for right here and right here, right, everyone? Everyone with me? I got 220 degrees for these 2 arcs. Well, that one's X. And you know, these 2 make up 220 degrees. So if I'm calling that X, what can I call this one over here? 220 minus X. Yep, 220 minus whatever the other arc was, which is X. And that's what's going to go into here. 220 minus X minus X. And I'm going to clean that up. Okay, clean up that parenthesis inside. Clean up that parenthesis. What's inside the parenthesis now? Here you go, 3. What's inside the parenthesis? Yep. Just like I did yesterday, I'm going to get rid of you can distribute the 1/2 if you want. I'm going to get rid of it. All right, so everyone, I'm multiplying both sides by 2 right now. And I'm going to get 64 equals 220 minus 2x. When you multiply by 2, it does not change what's inside the parenthesis. And then I'll let you guys go from here to find x. It's 76. Yeah, how about that? I should just follow my notes. And when you're ready, what do you got for me? 9?
X equals
72 degrees. Got it, Justin. Thank you. Okay. 60 degrees on number 5. Where is it? Inside or outside? 20. Where's this 60? Okay, so we know it's going to be equal to half of 2 arcs being subtracted. And I gave you 1 arc is x, but I know nothing about the major arc here. Look at last problem if you need a little hint. How can you express what the major arc is going to be? 6. Yep, it's going to be 360 minus x. So 360 minus x, that's the major one, minus the minor one, which was given as x. I'll let you guys go with that one. And when you're ready, 1, would we end up for x? 120 degrees. Okay, we all right? Angles on the outside. All right, I'll let you take about a 30-second breather here before we get to a big dog one. Parts A through F, huh? If you want to start reading it through. Okay, let's get after it. They tell me AB and AD are congruent. What are AB and AD in the diagram? Yep, those are 2 chords. So I have 2 congruent chords. Let me say that again. 2 congruent chords in the same circle. Arc AB, 150. And EOD is a diameter. Perfect. Okay, so 150. Okay. Anybody know why they gave me AB congruent to AD? Anybody remember if 2 chords are congruent? So are their arcs. Yes, nice job, Nick. All right. AB congruent to AD, that tells me that arc AEB congruent to arc AD. Yep. Congruent chords have congruent arcs. So what's arc AD then? Also 150. Before I get onto any of the angles, can you find the other 2 arcs? If you know all the arcs, you're pretty much golden in these big dog problems. EOD is a diameter. EOD is a diameter. Can you find the other 2 arcs? This is not drawn the scale of this diagram, but here you go, 16. Any idea on the other 2 arcs?
I said like arc AB is
60. How'd you get 60?
I decided sort of the remaining part.
Yep.
So I just got
Because you already had 150 and 150, which gave you what? 300, right? Everyone agree? Where's she saying that gave you 300? How many degrees in a circle, Maggie? 360, so you had 60 left over. All right, so that would be perfect because now this leads into part B, BAD. Here's how we're going to try to tackle it. BAD, Number 1, is that inside or outside the circle, BAD? Okay, everyone ready? Central. Inscribed. Yes. So what's the rule for inscribed? Half of its intercepted arc. So you're going to take half of what arc up here? 9?
Half of 60.
60, which gives me 30. Put it in your diagram. It may help you out later on. 30 degrees. It may help you. Okay, ACD, ACD, inside, outside. What do we got going on too? Outside, discussion's over. We know what the rule is for any angle located on the outside of the circle. It's going to be half the difference of 2 arcs. I just need your help on finding those 2 arcs. So find the 2 arcs in between ACD right now. ACD. What are those 2 arc measures in between? 17, what do you got for me? What's the bigger arc? Buck 50. And how about the smaller one, Max? 60. Nice job. And we end up with a 45-degree angle. I'll put it in there. I may need it. 45 degrees. Ready for EFB? 4, inside or outside? Inside. Everyone ready? Central. Inscribe. So it must be floater. And how did we find a floater yesterday? You took 1/2 and added, 2 arcs. Ooh, we run into a problem here, don't we? Or do we? I didn't label it on the diagram, but you can find it. EFB, here it is. What arc belongs to EFB? It's not the 150. 5? EB. Any idea how I can find the measure of EB? Because it's not 150. And remember, EOD is a diameter. That part was 60. Yeah. EB is what's left of half a circle. 120. Everyone else okay? 120. And it's vertical angles arc. So take a look at the vertical angle. What arc does the vertical angle belong to? 2? With AF? Yeah, AFD, and then what's the arc measure for AFD? 150. Half of 270, also known as 135. Everyone else all right? Were we going too slow or are we okay? I'm trying to slow this down so you see where everything's coming from. EDA, inside or outside? EDA, 16, inside or outside? Inside, yep. EDA, inside. Central? Again, this is what you ask yourself every time. Central, no. Inscribed. Yep, so it's going to be half of what arc belongs to EDA. Ooh, I don't know it. We didn't write it down, did we? This arc right here. Anybody help me find that arc? Because I didn't write it down. 17? 30, because it's a half circle. Part of it was 150. So take half of 30, end up with 15. 15 degrees, got it. And then finally, EDC. EDC. Where's 16? 16? You're on fire today, Maggie, right? Okay, EDC. There's 2 ways we could do it. All right, let me do it one way here first. I just didn't want to invade your space there. Maggie, what's CD? Name CD, that's a what? Intersects it just once, right?
The mock crash is now over. Please move to your next class. The mock crash is now over.
Okay. CD, that's a tangent, right?
Yeah.
And this is a diameter, also known as a chord. That's the one we went over today. You remember how to find an angle formed by a tangent and a chord. Yeah, just take a quick peek back.
Is half of
The arc.
The arc.
Half it, okay? And what arc does it belong to? See the arc that it belongs to.
is it 165?
Well, right here. So what arc is it? The 120 and the 60. So I'm going to take a half of the half circle, right? So that's going to be a 90-degree angle. Anybody else? How else could I have done that? There's another way. We have Maggie just told me this sucker was a tangent. Go, Justin.
Well, I did 135 or 180 minus 135 and got 45, and then I did 45, 45, 90.
Okay. That's the way I didn't even think about. You took this triangle right here, right?
Yeah.
You said, okay, next to the 135 is a 45, so it'd be a 45, 45, 90. I like it. I wasn't thinking about that. Emma? When you have a tangent and a radius or a diameter drawn to the point of tangency, they're always perpendicular. Nice job. If you want to start on because it's a packet and a bookwork night, if you want to start on one of the two problems on the next page, that's part of the packet work.